Hello guys, welcome to my YouTube channel. In today's video, I would like us to talk about variable speed drives. They are also called variable frequency drives. Variable speed drives are very useful instruments or components in the engineering industry, especially when it comes to controlling the speed of induction motors. In the past, when you want to control speed of an induction motor, you would use mechanical means, something like a reduction gearbox, to control the speed. Let's say you have a motor and that motor is running at a fixed speed, but then you want to vary the speed of the load, which means whatever the motor is driving. Then you would use mechanical means to control that speed. But the introduction of VSDs has made it possible now to vary the speed of the motor. You can have a gearbox that runs at a fixed speed or the fixed ratio, but instead of varying the speed on the gearbox, you vary the speed of the motor, meaning the motor is slowing down or running faster. So in front of me now, I'm having a Siemens Sinamics G120 drive. It's one of the mid-range VSDs from Siemens. When I say mid-range, I mean the power rating. Remember, we've got different types of motors. Got motors that are low power rating, let's say from 0.75 kilowatts to 5 or 10 kilowatts. And then you've got mid-range, which is motors 10 kilowatts, maybe to 100 kilowatts. And then we've got the higher range. So this one is in that mid-range. It's a very common VSD in that range. Simple to work with, easy and straightforward. But the main things that I want to show you today, you already know the function. We were trying to control the speed of the motor. So we're going to be getting AC supply into the VSD, and then that AC is at a frequency of 50 Hertz. Then internally inside the VSD, you've got something called a rectifier. That's going to convert that AC to DC. And then you've got as well as an inverter inside, which is going to convert the DC back to AC. But the DC that you're converting back to AC now, when it comes out as an AC output, it comes as an AC output that has a variable frequency. So by changing the frequency of the output, you are able to change the speed of the motor. To calculate the speed of a motor, we have a formula that says the speed of the motor is equal to the frequency multiplied by the number of pole pairs and then divide by 60. So the fact that you can change the frequency, you automatically are able to achieve the change in the speed of the motor. That's basically the summary of what the VSD does. So it gets the AC, changes to DC, and then modifies the DC, changes back to AC with a variable frequency, and then you are able now to get that variable frequency that to send to the motor. At the same, the voltage can still be 240, or it can still be 380 volts, it can still be 525 volts. But now what the difference is that the frequency that you are breaking is changed. Okay, another important thing that the VSD can be used for, you can actually have a single phase supply. Let's say you've got a single phase supply. There are those VSDs that can do that. You get a single phase supply into the VSD, it's still AC, and then you are able to get a three-phase supply. But that's not the main topic. Now let me just take you through the wiring and the components that are involved. So if you understand induction motors, in the past or traditionally, you will find that induction motors, you run them with a direct online. So you'll have an isolator, and then after the isolator, you'll have, let's say above the isolator, there can be maybe a circuit breaker. But in this case, instead of you having the conductor to control the starting and the stopping of the motor, you let the VSD do that. Okay, in this circuit that is in front of us, we have an isolator. You've got your three phases there, red, yellow, blue, or red, white, blue. In this case, we are having 525 volts because it's in the mining industry. But in other industries, you'll find that it's at 380 volts. Okay, your three-phase input would enter via that isolator. That is basically what you use to isolate and lock out, and when you want to work downstream. And then you've got a set of fuses. Okay, we understand that fuses are there for overcurrent protection. So the fuses will be rated to the size of the motor, so that if everything fails, then the fuse can blow, and then your motor is protected. In this circuit, we also have a contactor. It's not always necessary to have a contactor, but in this case, we do have a contactor. that you can also control to switch the power circuit, which means your 380 volts. If this contactor is on, or if this contactor is off, meaning the contacts are open, the 380 volts won't go through. But if the contactor is closed, then the voltage is going to go there. Then these three wires, these ones, the three wires that are coming in, they go through a current transformer. That current transformer helps you to measure the current that is going to the VSD, obviously. And then this is your input to your VSD. Those three phases, you've got three phases plus earth in your input. And then this side, this is your outgoing to the motor. Three phases, 1, 2, 3, that is going to the motor. Then this is your VSD, which is the electronic circuitry that I was telling you about, that it does the conversion. It's here. But this VSD has got two parts. You've got a power module, which is this one, and then you've got a control module. The power module does all the heavy work. If we are talking about electrical, you can say it's the power circuit. That's where the high voltage is going through. But then you also have a control module. This control module, like I said on my short video, is the interface between this VSD and the outside world, meaning your controller or your DCS system or your PLC. This is the small part of the circuit. You have 24 volts here. This is the, first of all, you've got a Profibus communication, which means this device is connected on a Profibus network to the DCS system. And then you've got some digital outputs and analog outputs that you can use. Let's say you want this VSD, when an e-stop is pressed, you want it to go into an error state. That's where you're going to wire your other components there. You will have inputs, you'll have outputs, you have digital inputs, you've got analog inputs and analog outputs. But most of the time, we don't use all of them. But those are just the features that are available. And then you also have got this Modbus cable coming here. This Modbus cable comes to your control panel. So there is your control panel. There is it. You can use that control panel actually to set parameters. Let's say you want to change the current setting, you want to change the voltage, you want to anything. So as a human being, this is your communication between you and the VSD. Okay, another important thing that I want to mention here is that when this VSD, when you buy it, when it's new, it comes empty. It does not have parameters, there's no settings, it does not know the type of a motor that you're going to be working with. So you need to insert those values. That's where the motor nameplate comes in. Need to look at your motor, the motor that you're going to connect, look at the power rating of the motor, the voltage settings of the motor, the power factor of the motor, all those settings that you're taking from the power factor, you are telling your VSD so that the VSD can control your motor, knowing very well that, okay, this is the size of the motor. Your current setting, which is your full load current of the motor, and your tripping current of your VSD will be based on the information that you get from that nameplate. There's many ways to insert those values. The first one is this interface, which is called the operator interface. But the second one, you can download these values via the Profibus network using a Siemens software. It's called Sinamics Starter. We will look at it at a later time, but that's a software that you can use. The software makes it easier to do the settings because it's like a table. It's like an Excel spreadsheet where you can look, see at all the values. This is a voltage, this is a frequency, this is a motor speed, this is a power factor, all the values that you want. But if you use this operator interface, you will have to insert the values one by one. Okay, as I close, the last important thing that I think is important, this is more like an intelligent type of a motor control. So it will show you warnings, it will show you errors. When the motor is overloaded, you'll get warnings. That information, again, you can read it via the Profibus network, which is up at the software that I mentioned. But you can also go into the menu of this device. I'm going to make a YouTube short just to explain how you go through this menu. But that's where you actually enter, looking at all the parameters and all the important stuff. Sharp. All right, okay. Thank you for watching the video. If you like the video, please do subscribe. Don't forget to share the video. Don't forget to like the video, but please do share with the people who might find it useful. And also do like and subscribe. Thank you. Goodbye.